recording and.
Okay, so what's the amplitude here, guys?
The amplitude is 1/4.
1/4. And period is 2 pi over b.
Oh, pi.
So 2 pi over 2, just pi. Okay. Phase shift cross off. We're not doing phase shift. We've never done phase shift in this class. We're not going to do it. Just cross it off.
And then displacement is 1.
Displacement is 1. So the midline is at y equals 1. So I'm going to draw my midline like this. Y equals 1. So it's a, I'll do a dashed line. Thing is the foundation of the graph. Okay, yeah, A is negative, but we still say the amplitude is positive, but we'll go down, right? Okay, so this is sine, right? How does sine generally look? Generally looks like this, right? That's how sine generally looks. So I'm going to start over here. And by the way, if you were plugging 0, right? Plug in 0, what's 2 times 0? 0. Sine of 0 is 0. Then 1 times 0 is 0. 0 plus 1 is 1. You should be starting at 0, 1. If you're plugging 0 for theta, your y value would be 1. Now, the period is pi, so you're going to end right here. And we always need 5 points, right? We need 5 points. So, and the amplitude is 1/4. So I have to go down 1/4. Because what's every tick mark? Like, this is how many units from here to here. So my 2 fingers, how many units is that on the y-axis? Well, let's say increment 0.5. Because my amplitude is 1/4, I got half of that increment. That's why I only went down that far, right? So this is 0, 1. This right here is pi over 4, comma 0.75. Yes, I'll ask you to do that, yes.
What?
Because it's going to help make your graphs more accurate.
You're labeling?
Yeah.
Oh.
What's this point going to be right here? Pi over 2, comma what? 1, right? Then it's going to hit a peak right here. And what are those points going to be? Because the plus 1 on the right. That's why.
Yeah.
1.25. And then this will be pi, comma 1. So your curve looks like this. And that will get you full credit. This will be an 8-point problem. This will be an 8-point problem. I will give you 1 point. We'll label these correctly. 1 point for the amplitude, 1 point for the period, 1 point for the midline. So I'm going to ask exactly this. It's going to look exactly like this. Okay.
Does that have to, like, for it has decimals like 0.75? Could you just do 3/4?
Yeah, that's fine. And actually, I don't think I have decimals anyway. This is kind of weird. But yeah, but I mean, yes, you gotta. Oh my god. So what I'm gonna do is I'm not gonna these are not gonna be labeled. Yeah. So you're gonna label them yourself. Yeah, I'm gonna keep more generic. Because I want you guys to come up with the labels on your own. So okay, questions on that one? How that one's done? We're good? Okay. So you'll have 1, 2, and 3 to try on your own. And the answers are already up in Schoology. If you click on test review or click on homework 14, that's where you'll find it. All right, let's do writing an equation. Let's do a cosine one. Let's do number 6. Okay, so I will give you this. Y equals A times cosine bracket B times theta bracket plus D. Or you can use X instead of theta. I don't really care. Okay, so let's figure out what A is. Let's figure out what B is. Number 6. Number 6.
Oh.
So let's figure out what A, B, and D are. And you're asked to do, excuse me, you're asked to do cosine. So where's the midline?
-1.
Good. -1. What do you guys think the amplitude is? That's a little tricky. The amplitude is a little tricky. -1 goes right to the middle.
0.4.
Because it goes above -1 and below -1, right? Equal amounts. So what you're doing, JP, is you're looking for what line goes right through the middle. When I say the middle, like horizontal line. And also you're looking for equal spacing between the peak and the low point. So -1 is right in between the peak and the low point. That's what we call it midline. So what will be the midline for 7? What do you think? Yes, exactly 2. All right, guys, what's A now? A is a little tricky. What do you guys think A is? 0.2. Good. 0.2. I get the errors.
Yeah, how did you get that?
How did you?
Well, I saw like how spaced out.
Yeah, excellent. How many spacings are from 0 to -1? How many spaces?
5.
5, and so 1 divided by 5 is 0.2. 1/5.
Wait, what?
1 divided by 5.
Yeah, I get that. How'd you get 1 to 1? Where's the 1 from?
That's the distance from here to here. The whole distance is 1. To go from 0 to -1,
Oh.
right? The whole distance is 1, and we're breaking 1 into 5 equal segments, or 5 equal intervals.
Okay, I get it.
You can leave this 1/5, by the way. You don't have to write 0.2. If you want to write 1/5, that's totally fine. Okay, now the period, let's be careful here. We start here and we end here. How long is one cycle here? Right, so the period is pi. But we can't say b is pi. How do I solve for b? Okay, so what's b going to be equal? 2. Good, excellent. Now you got it. Let's write it out. Y equals 1/5 or 0.2, I don't really care, times cosine of 2 theta minus 1. Now it's hard to show work for this because we're really kind of just looking at the graph and extracting information. But if you do write like period is this and solve for b, that gives you some partial credit in case you make a mistake. Or if you tell me a is this or d is this, at least I know like the wheels were turning and you were thinking through the problem. So 2 pi over b equals pi. And then if you could solve it by cross multiplying and isolate b. Also, if you kind of think about it, if b is 2, the 2's would cancel and be pi.
Where's the 2 come from?
Well, 2 pi. 2 pi over b is a formula for.
Yeah, I know. For B, how'd you get B? Because doesn't it end?
Yeah, no, but what does b have to equal to make this work?
Oh, to this top, so it's to pi.
Right.
Oh, I see. Okay.
Right. No, but if you want a more mechanical way, what you could do, Charlotte, is cross multiply. If you multiply both sides by b, you get this and divide both sides by pi. So if you want to be more mechanical about it, totally fine.
Okay.
It's a little extra work, which is not a bad thing in case you make a mistake. It's good to show work.
So it's 1/5 cosine 2 theta.
And then -1 on the outside. So you'll have a chance to do a similar problem for number 7. Okay, was there a question? I can't. Yeah, quick. Oh, sorry. Yep. Same methodology, right? Right. Because now it's starting at the midline, which is what cosine does. Cosine starts at the midline and does. Because traditionally sine is this, right? But this is going to be flipped over. Because sine usually looks like this that I'm tracing right now. But then this is going down, then up. So your A value is going to be negative for that one. All right. I'm going to do one of the more complicated inverse trig ones. And then I'll let you guys get to work. Okay, let me do this. Let me do 17, 21, and 19. Let me do those 3, and then I'll end the video, and then you guys can get to work on those stuff. Okay, for 17. So all this, it is, yes. All that equals theta, because that's an angle.
135 degrees.
So theta is going to be, thank you, 135 degrees. That's very good. X coordinate, Y coordinate. Yeah. Yep. So that's the same forms from last time, plus the default ranges that we need. Yeah. So tangent 135. Cosine's X. Yeah, that'll be on the formula sheet, so don't worry about it. Okay, now what's tangent 135 using your unit circle?
It's just 1, isn't it?
Close.
Oh,
It's
-1.
it's negative root 2 over 2 over root 2 over 2.
Wait, I thought it was the other way around.
Y over X. But it wouldn't matter anyway. So. Oh yeah, the negative. Yeah, the negative. Yeah, no, you're right, Charlotte. The negative should have been down here, but it doesn't matter because it'll still be it'll still be -1 anyway. No, because you have the final answer, right? -1. No, she's really nice. I don't know. It's math. We're particular people in general. I don't know. Like, I mean, it's Precalculus. You could leave it. You could leave it like this too. That's fine. If you want to leave it that way, that's fine.
Will you give us that towards like y over x or something?
Yeah, I'll say tangent y over x, sine is y over r. Because yeah, it's the same form as last time, plus some more stuff.
How would you do y over r?
No, this is tangent. It's gonna be y over x.
Yeah.
So you look at 135. At 135 degrees, the coordinates are negative root 2 over 2 and root 2 over 2. So you're doing y over x, and that gets -1.
Yeah. But so
Mhm.
for like tan
Mhm.
for cosine, you'll say like it's just the x value.
Yeah, I mean that will be on the formula sheet.
Okay.
Yeah. I mean, when you're dealing with unit circle, I mean, I'm gonna say x over r, but when you're dealing with unit circle, r is 1. So okay, 19. 19 is kind of crazy. It's a little crazy. Well, first of all, let's make that inverse sine. Don't worry, I'm not gonna write arc sine. I didn't use that verbiage with you guys, but it's the same thing. It's an old school way of saying inverse sine.
So it's tangent of inverse.
Sine of 5x. Okay, now this is kind of interesting. We see 5x. It's weird. So this will clear it up. So first of all this, just like we did for number 17, all this is theta. Okay, all that equals theta. So theta is inverse sine. Now, there's one little wrinkle I'm going to add here. Instead of writing just 5x straight up, I'm going to write 5x over 1. 5x over 1 and 5x are the same thing, right? Whenever you divide a number by 1, it's the same thing. But why am I doing that?
Oh, because you get the hypotenuse.
Yeah, exactly. Good job, Charlotte. Exactly. Yes. By doing it this way, I know sine theta is 5x over 1. So theta is going to be the inverse trig, because whenever you have inverse trig, that's always an angle. The output's an angle. So I deliberately set theta equal to the inverse sine part. So inverse sine of 5x is theta. Right? Because that's what we did for number 17, right? Remember, I let all this be theta. And then I had to see what angle got me that, which is 135. Because what does this really mean? This means that cosine theta equals negative root 2 over 2. And where does it happen on the unit circle at 135?
Wait, Mr. Are you going to be
I'll be on Zoom. But hold on, let me talk about that in a sec. Because I'm going to be also available Thursday night as well. I know, that's what I'm saying. Test Friday. Okay, so anyway, let me back. So that's theta, right? That's theta. Now let's draw a triangle. Okay, so we're almost here. If I put theta here, 5x and 1 go here and here. Do you guys see why 5x and 1 go in those two places? 5x is the opposite. 1's hypotenuse, right? So if that's the opposite, and that's hypotenuse. That's why I deliberately wrote that as a fraction. So that's going to go opposite that angle, and that's going to go in hypotenuse position. Now, I don't know. How do I solve the
5x plus
a squared plus 5x squared
plus
equals 1 squared. Or a squared plus 25x squared equals 1. A squared is 1 minus 25x squared
Wait, 25. Whoa. Wait.
I'll back that.
Wait,
I'll back away so you guys can see it.
what did you do?
Pythagorean theorem.
Yeah, so it's 25 squared
I'll write it again.
equals 1.
Yeah, so if this is A,
Oh, I see what you did. And then 1 minus 25x squared. So wouldn't A equal?
well, no, hold on. So you're doing Pythagorean theorem, right? So A squared equals 1 minus 25x squared. So A is going to be the square root of that, right?
Can you simplify it more?
You can't, unfortunately, because of PEMDAS. Because without realizing it, square root is an exponent. And also, this whole thing's inside the square root, so it's almost like there's an invisible fraction.
Wait, because like 25x squared can be simplified.
No, because it's 1 minus.
Oh.
That's the reason why. Like, for example, if I had the square root of 25 plus 1, can I square root to 25? No, I can't, right? I have to do 25 plus 1, then square root afterwards. You'd be bypassing the order of operations if you did that. So you don't want to do that. So anyway, that's what A is.
It's 5x over root.
So the tangent, right. Yes, exactly.
Do you have to simplify that?
No, you can't.
No, I mean like get the root out of the bottom.
Oh, no, I don't, I don't care. No. That'd be cruel.
Do you think like Miss Perron will make us do that?
I'll ask her to diff just for you. Yeah. Okay. We'll still have 2 more units.
Final, right?
Yeah, so after this we'll start chapter 5. Chapter 5 I think will be 1 unit. And that test I think will be given right before Thanksgiving. Because Thanksgiving will come up pretty fast if you think about it. And then after Thanksgiving there'll be a short test on chapter 6 is only 2 sections. And then there'll be basically 2 more tests, but one will be kind of small, and then the final. So anyway, so that's 19, a little complex. Let's do one more similar type problem. It's right here.
Oh, okay.
In purple. Again, I'm recording this so you guys can watch it again. I'm recording this.
21, you said?
Yeah. And you might want to be careful when you bring up names of the teachers because this is being recorded. Just teasing, don't worry about it.
I didn't say anything bad.
I'm just giving her a hard time.
Oh.
All right, don't worry about it. All right, 21. Mean. Strict. Okay. All right, here we go. So this equals theta again, right?
You can record the other class.
Sure, why not? Or I'll edit it out.
Sure.
Okay. Okay.
Can you actually edit these?
I don't, because I get kind of lazy because I have to use another software to do that, and I'm kind of lazy to do that. Plus, that just becomes now becoming a video editor, and that just takes really long, and I just want to click a button, upload. So, all right. So, yeah, theta equals inverse cosine negative 1/4, or cosine theta equals negative 1/4. Now, where's cosine going to be negative? What quadrant? Quadrant 2. And remember, we have default range. It's also in quadrant 3.
But we can't because it goes to 180.
Right, exactly. Because cosine, yes, exactly, right. So it's going to be in the second quadrant. It's in the second quadrant because cosine is negative. You can't go quadrant 3 because the default range from 0 to 180.
So then it would be -1.
So this would be -1, and this would be 4. Hey, Anthony, go ahead.
Are you also going to give us like the default?
Yes, of course. Yes. Okay. Solve for that side.
Why did you flip it? Oh.
We'll flip what? Okay.
X squared is 15. Root 15.
So it's root 15, exactly. So that's root 15.
For these, you don't really even have to draw the triangle. You just need to do that.
Yeah, it helps to draw so you can visualize it. So now you want sine theta. So what's my sine going to be here? Opposite of hypotenuse, or y over r. Perfect, nailed it. Good work.
Wait, so like, say
Mhm.
you did it up in the top, like, doesn't it really depend on where you put data? So like, if you put data up in the top and you put it in the bottom corner. Because it has to be touching.
Yeah, it has to be touching the origin because we're drawing standard position. I mean, technically this is theta, but this is the reference angle that we're using as a acute angle. So, okay. So you guys have plenty of practice. I have the solutions all in Schoology. If you feel like you want to start with this, you feel like this is the one area, okay, uncooled graphing, I got it. I really want more practice here while we have this time together. Start, you don't feel like you have to start with number one. If you want to start in the middle, go ahead. And there's some word problems at the end. I won't do those. I want you guys to kind of work on it. I'll look over with you if you get stuck. Actually, let me do one more with you guys. Let me do number 30. Actually, no, I'll wait till the end. I'll let you guys get there. Okay, let me stop the recording.